All right, this video starts chapter 3, sections 3.1 to 3.3. And in this video, or in this chapter actually, it's all about inequalities. So this should be pretty quick because it's very similar to equations, solving equations, just with inequality symbols. And if you remember, the differences in inequality symbol has a greater than or less than or greater than or equal to, less than or equal to sign. Other than that, it's the same though. So the first thing, if I want to graph, okay, let's do 1 and 2. If I want to graph number 1, okay, x is greater than 5, just put, and your teacher's requirements may be different, but this is all I require. Put the number you want that you have in the middle, so x is greater than 5. Put one number larger than 5 to the right, and then one number larger, or smaller than 5, excuse me, to the left. Okay, and it could be any number you want, as long as it's bigger one to the right, and the smaller one is to the left. Okay, now here's how you do this. So 5 is the number we're interested in. All right, since there's no equal to bar underneath, it's just a greater than sign, this gets an open circle on it. Okay, this gets an open circle on it. And then now what we do is we just shade the appropriate. So the shading on our graph is going to represent basically where x is. Okay, so it says x is greater than 5. Well, where are the numbers greater than 5 at? So in other words, is 6 greater than 5 or is 4 greater than 5? Well, obviously 6 is, right? So 6 is greater than 5. When I plug this number in, all right, for x, that gives me a true statement. I always want to shade toward the true statement. So that would be this way. If I were to plug the 4 in here, all right, the 4 in for x, it would say 4 is greater than 5. That's not true. Always shade where the true is. Okay, look at number 2. So negative 3 is going to be the number that goes in the middle. A number smaller than negative 3 would be negative 4. A number larger than negative 3 would be negative 2. All right. Now, this gets a dot on there, all right, a circle on there, but this time we color the circle in. It's solid, and the reason is because of this equal to bar that's underneath the less than sign. Okay, so if it has the bar underneath, we color it in. Notice this one has the equal to bar underneath, and number 1, that one doesn't. So no equal to bar and number 1 gives you an open dot. Equal to bar gives you a closed dot. And it's the same way, all right? X is less than or equal to negative 3. So less than, where are the numbers less than negative 3 at? Well, they're to the left. They're this way. All right, and again, the way you can get that is if you plug this negative 4 in for x, you have negative 4 is less than or equal to negative 3. That's true. We always shade where true is. All right, so just working backwards a little bit now, we get the graph we want in the inequality. So really simple. If I look at number 1 on example 2, all right, x is less than 12. Remember, x is where the shaded part is. The shaded part's right here. So x is less than negative 12. I don't put a bar underneath, all right, the less than sign because of this dot right here being open. Okay, number 2, actually, let's go to number 3. I'm sorry, let's go back to 2. I want to hit a couple of things here. So x is less than or equal to this time. Why? Because the shading is to the left, all right, which is less than the 0.04. Or 0.4, excuse me, and I get the equal to bar underneath because it's a solid dot. All right, pretty straightforward. Okay, now actually solving these. So all of the solving's the same. I'm only going to do a couple of these. I'm going to solve it and then just show you how to handle the questions here. All right, and these obviously can get really complicated, just like solving equations can, but the whole premise is exactly the same. All right, so all I do is I get x by itself, no different than if that was an equal sign. So it's x is less than 3. All right. If they want me to graph, 3 goes in the middle, a number smaller, a number larger, open dot on the 3 because there's no equal to sign underneath the less than symbol, no equal to bar. X is less than 3. So where are the numbers smaller than 3? They're over here. Okay, same thing over here. All right, so y is greater than 4. So I put 4 in the middle. Number bigger to the right, number smaller to the left. It says y is greater than or equal to 4. Open dot and shade. Okay. All right, here's the catch on these. If you ever move a number that's attached to the letter and it's negative, so in other words, if you multiply or divide both sides by a negative number, we have to flip the way the inequality sign faces. All right, so if I divide by negative 4, all right, I divided both sides by that negative number. this is going to flip directions. 12 divided by -4 is -3. Notice how the sign flips directions here. Okay, so my answer is z is less than -3. And if I were going to graph that, open and this way. Okay, so that's the only catch on how you do inequalities, is if you multiply or divide both sides by a negative number, both sides of the inequality, you have to flip the direction that the arrow faces. All right, let's do a couple setting up of word problems here. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. All right, define a variable and write an inequality for the temperatures at which Ray can turn on the air conditioner. All right, we're going to skip the graph, but just so you can see an idea here. All right, so define the variable. Let's say T equals temperature. All right, for which Ray can run the AC. Okay, so it needs to be at least 85 degrees. Well, think about what at least means. At least 85 can be 85 or more, so the temperature can be greater than or equal to 85. I started to write 35 here, greater than or equal to 85 degrees. Okay, that's how you set it up. Very similarly for the other ones. All right, just use that logic, you should be fine.